Hello, this is Shakil Ahmed. In this tutorial, we will discuss about the post-hoc test that is conducted when we reject our null hypothesis in one-way analysis of variance. The data set of diastolic blood pressure of patients in three different treatment groups, treatment A, treatment B, treatment C, and we just apply one-way analysis of variance to test whether there is a difference between the means or not. The null hypothesis is that all means are equal, and the alternative hypothesis is that there is no difference between the means. So let's apply the analysis of one analysis of variance using data analysis toolpath option. We have single factor analysis of variance, and I select the input data. I'm selecting all the columns with all the cells. Excel will automatically select the data with the columns with data, and the other cells will be. And the groups are column wise, so I'm selecting the columns, and the alpha is 0.05. And wells in first row, I think we should select it. As we are selecting these three columns and the first row, and then the result will be saved on a new worksheet. And okay, so we got the results, and the F statistic is 4.23, and the critical F value of the F statistic is 3.4. So we reject our null hypothesis, and the three means are not equal. Now we will check the which two pairs of which two combinations or two means are not equal, and two which are equal. So we can see the averages here. For example, average, the smallest average. I'm just selecting to color it as the smallest to the largest. Here is the coloring. This is the smallest, this is the second smallest, and this is the largest. And we will perform an analysis of variance. These are the sample sizes for the three, and we have the variances as well. But we are using Indian square. Basically, we need to find a statistic that is called Tukey statistic, that is Q. Or I just want to write it here. It is the difference of two means, the pair difference, divided by standard error of this difference. Just we need. And what is standard error? Standard error is basically the square root of the standard error obtained. Standard error divided by the sample size of that group, and the second, and then divide by the. For example, you have, I will just write as sigma 1 square, sigma 1 square plus divide by n1 plus sigma 2 square divide by n2 under square root. And as the variances are equal, and that is mean square, so we just can take variance common, and the average, basically we are dividing all the things divide by 2. So in other words, we can write this formula as And just shorting this formula, just write it as 1 hour and 1 and plus 1 hour and 2, and just write sigma zero point 0.5 into sigma, that is we are dividing this variance divided by 2 and 1 hour and 1 plus 1 hour and 2, and then whole square root. So this is the test standard error, and we find the difference each pair, and then we will get the uh, Q statistic for each pair. For example, I am going to compare the two pairs one by one. For example, group A versus B, A versus C, versus. So first we will find the difference, and then we will find the standard errors, and then we will find the Q statistic, and then we will find Q critical, and we will just compare the observed value of computed value of test statistic with the critical value. So what are the differences? A minus B, we can, this is uh, treatment A minus mean of treatment B, A minus mean of treatment C. So these are the differences, and we will find the standard error square root. It will be easy if you can just write the sample sizes here. For example, here we are using A and B. You can just write 1 and 2. So we are writing 1 A and B. So the sample size for A is 9, B is 10. Here A and C, 9 and 8. And here sample sizes are 10 and 8. So we can just find the standard error as the square root and 0.5 into standard error, mean square error, and 1 over. And you can fix this by using the dollar sign, as we don't need to change this. Other two will be changed. This plus 1 divided by this, and bracket close, and one more bracket close as this are the square root. So this is the standard error for first, and you can just drag it. You will get standard error for other two. And then the Q statistic is this divided by the difference divided by this standard error. So now we can see there is no significant difference between these two pairs, but this is it seems significant. So we can check the critical value of the chi-square. We can just write critical value 2 is Q table. The key is Post-Hoc Q table. So this is the key Q table, and we have number of treatments, 3 number of treatments, And what is the error degree of freedom? Error degree of freedom is 24. So uh, the treatment number of treatment is 3 and degree of freedom for error is 24. So we are using this value. The first value is for 0.05 and the second value is for 0.01. So we use 0.05 alpha and this is our critical value. And if this value is greater than this value is greater than the critical value, we reject S naught. Otherwise, we will not reject S naught. So there is no significant. This is not significant, and can just copy this, and this is also non-significant. So this is just a post-hoc analysis of the one-way analysis of evidence. When we reject our null hypothesis, we need to check whether there is a significant difference between the pairwise means.